Assalamu alaikum students, this is the second part of the mass spectrum. In this video we will study the peaks in the mass spectrum of an organic compound. So let's start the video. First of all, rules to identify organic compound on the basis of the peaks. Basically, the main use of the mass spectrometry is in the identification of organic compounds, as in other forms of spectroscopy. A substance can be identified by matching its spectrum against the spectra of the known substances which are already stored in the database. This technique is known as fingerprinting. The high energy electrons knock out electrons from the molecules and break the covalent bonds. So in this way, fragments of the molecules are formed. So basically, the whole molecule converted into smaller fragments. Figure shows on the next page shows mass spectrum produced by propanone, a molecular ion. So basically, when an electron is removed from a molecule, it is known as molecular ion is formed when one electron is removed from a molecule to form an ion with a single positive charge. For example, CH4 convert into CH4 plus E minus. E minus means one electron is removed from CH4. You should remember here that no atoms are removed, only the electrons are removed. Here is a mass spectrum of propanone. So basically, the propanone converted into three major fragments, one with 15, one with 43, the next one with 58. So that's why the different peaks are formed. Basically, the peaks are formed on the basis of the number of the fragments. High resolution spectrum. High resolution mass spectrometers can distinguish between ions that appear to have the same mass on a low resolution mass spectrum. There will always be a very small peak just beyond the molecular ion peak at a mass of m+1. This is caused by molecules in which one of the carbon atom is 13C. 13C means 12C plus 1. That's why we call it as m+1. This is shown in the mass spectrum of the ethanol in the figure. So you can see here is a broad photograph showing the mass spectrum of the ethanol. You can see here this is m+1. This fragment contain C13 along with C12 as well. And the other fragment, we can have a fragment here. This one, if you see, this one is 27, then this one 29. So in this way, there are different fragments which are formed by the breakdown of the ethanol. Now this is a formula to work out number of carbon atom in any compound. N equal to 100 over 1.1 multiplied by abundance of m+1 ion divided by abundance of m+1. Now solve the example. This is a question from winter 22 paper. In the mass spectrum of compound Z, the relative abundance of the M and m+1 peaks are in the ratio of 13:1. You should remember that 13 is the ratio of M peak and 1 is the ratio of m+1 peak. So we will simply put the formula which I just shown you before, this formula, and then we will put the values. 100 over 1.1 multiplied by 1 over 13. We got 100 over 14.3 equal to 6.99 or 7. It means that our compound contains 7 carbon atoms. You can see yourself. Butyl butanoate, it contains 8 carbon atoms. Hexane 3-on, it contains 6 carbon atoms. 2,2,3 trimethylhexane, it contains 9 carbon atoms, 6 for the hexane, 3 for the 3-methyl groups, and 3,3-dimethyl pentane. So 3,3-dimethyl pentane, it means 5 plus 2 carbon atoms, a totality of 7 carbon atoms. So it would be the answer. So this is a video which is on the mass spectrum. I will make another video regarding m+2 and m+4 peaks, and that would be the third video of the mass spectrum. Thank you very much. See you soon. Allah Hafiz.